Okay, so as many of you will have seen, the activity for this week is available. Programming exercise 3 is up, as you're all hopefully aware by now, and it's going to be due middle of week 9, so just after your tutorials during that week, or sorry, your workshops during that week. That all said, obviously you want to have as much done before the workshops as possible, because it's not going to be feasible to it's not going to be remotely feasible to be able to finish it within the same day as your workshops. And also, don't forget about the major project. It's worth a much greater proportion of your overall course grade. And that's something that hopefully you're working away on in the background there, and we'll be doing so over the next few weeks. So please don't forget about that, because it's worth a lot more. Now, mid-semester break is coming up, and I will be available for consulting next week and throughout the mid-semester break if anybody wishes to discuss anything or make a meeting to do that. If I can do it via Zoom if people prefer that, or in person, depending. So I have set times on Mondays, Tuesdays, and Thursdays normally that I am available. During the second week, I'll make some additional times available because I'm not available during Monday and Tuesday, and we'll cover this again when we talk next week. Okay. So this week, the resources that I asked you to take a look at were specifically regarding JavaScript itself as a language, how it handles events, and this idea of the event loop and how the event loop deals with concurrency and JavaScript as a language. In addition, I suspect many of you might have some more questions or thoughts about Petrinets for exercise 3, so I'm happy to discuss those further. So starting off with events and event loops, how do people feel about the way that JavaScript handles events as a language, potentially versus how other people handle events, or not other people, other programming languages handle events? Some of you might have seen the resource that one of your classmates posted on Piazza as well. I've had a look at that, and that I think is also an excellent resource for helping to understand this. I guess to start off with, why are we talking about events, the event loop? Well, I mean, obviously this is event-driven computing, but why are we specifically talking about this concept of the event loop in JavaScript? And the reason why I wanted to talk about this was, first of all, because we think of events as this sort of lofty, abstract concept in event-driven systems, where an event comes in and like suddenly like a bunch of stuff happens as a result of the event occurring. But how do we actually go about building a system based on events? And there are a few different models, but many of them rely on this core concept of an event loop. So the basic idea with an event loop being that and there's a reasonable diagram for this, but the basic idea with an event loop being that events come in, and those are typically managed by either an external framework, another thread, or the operating system itself. And those events come in and they get queued up and placed in a queue. And the actual programming language itself, or the runtime for that programming language, won't necessarily execute events immediately as they occur. A lot of frameworks tend to queue the events up and then handle the events one at a time on a main event loop thread. This is especially common in graphical user interfaces, which is why you'll find that on a lot of GUI programs that you use, if the program is running slowly for whatever reason and you click on something and it's not working and you click it again and again and again, then eventually when it finishes doing whatever it was doing that was making it run slow, all of a sudden it'll do 10 of the thing that you asked it to do. It'll handle all of those individual events one at a time. So that was the main thing that I wanted to bring up as far as what we were trying to get out of the content this week. It has some interesting implications for concurrency. So what I mean by that is we know that JavaScript specifically is a single-threaded language. And even the idea of callback functions and other bits and pieces, we tend to think of those as things that can happen concurrently, but realistically, JavaScript is still a single-threaded language. So what am I talking about when I'm talking about concurrency? Process function without stating the function name. That is an excellent question, which we will get to. Absolutely. So where was I? My goodness, I lost it for a second there. So the idea, JavaScript may be single-threaded. A lot of other programming languages allow for having multiple threads that can execute at the same time, but they keep all of the main system events coming in on a single event loop. So what will happen is this main event worker thread or this main event loop it'll just sit there waiting for an event to occur. And then when an event occurs, it gets put into the queue. And if the system is not processing another event, it will take an event out of the queue and it will start working. It will process that event. And eventually, once it finishes processing that event, it will go back to the queue and it'll pick up the next event that occurs in that queue. Now, depending on how you've written your code, a lot of basic single-threaded applications, that'll be it. So you can have this idea that the code itself is blocking other events from occurring, even though the events may have been queued up at very close amounts of time. So if you have your code in that main event loop that has a lot of computation to do and is going to take a long time to run, that can prevent other pieces of code or other events from getting handled immediately and potentially delay them a significant amount. So those are the things that we have to be specifically aware of with JavaScript. Other programming languages have a similar structure. However, many other programming languages are multi-threaded, which means that if you have something that will take a long time to do, you can actually transfer it off to another thread of execution of the program, and then the main event loop can continue processing events in the system. JavaScript doesn't have that. If you have something that's computationally, actually it kind of does. There is a relatively new API for doing that, but it's not commonly done. So we try to keep efficiency in mind as much as possible. Otherwise, we'll find that the web pages or just the programs that we're working on become slow and unresponsive. Okay, so that's the event loop and concurrency. I've gone backwards a little bit on this. Well, those are some thoughts on that. Do people have questions about the event loop, the idea of concurrency and single-threadedness and those sorts of things? And then we'll come back to callbacks. process is actually passed function by class. I'm not entirely sure what that statement. Oh, right. Okay, you're answering the question from before. Okay, so moving on to events and callbacks. So in JavaScript, one of the really interesting things to note in JavaScript is that everything is an object. Everything is an object unless it's a primitive. But otherwise it's an object. So when I say everything is an object, I mean everything. Arrays are objects. Strings are objects. Objects are objects, obviously. But functions are objects in JavaScript. So we can do some really neat stuff given that functions are objects. So if I bring up a console, oh my gosh, my Zoom controls are in the way of my console controls. Goodness, no, go away. This isn't going to work. Bear with me a second. I'm going to have to. Okay, so what I can do if I define a function, so function hello, and it's just going to log hello, some text to the console. It doesn't return anything, but if I just run like so, okay, fairly straightforward. So that's a function. Now, what I could do if I wanted to is I could, what functions in JS handling with network request? That is an excellent question. So I'm going to come back to that when we finish talking about callbacks and this. Okay, so we've got hello, it's a function. Now, this is one way of defining a function, but I can a different way that I could define it is by putting in a variable. So I could say variable I equals, again, function. In this case, I can just provide the function without a name, like so. I think I have to put the brackets here. Okay, so now if I run hi, now hi is a variable, but if I run hi, you'll see that it runs that function. So now I can start to do some interesting things. For example, I can create an array and I can put hello and hi. Now, even though we've defined these functions in two different ways, because they both have names, one of them, the name is basically stored as the variable name, and the other function is the function definition. So I can do this var functions. Cool, so now I have an array of functions, and if I print that out, you'll see that it's got those two functions in the array. So I've actually taken functions and I put them in an array. So now I can do something like for let's fn of functions. So this is just a simple for each kind of loop. I could then do like so. I realize this text may be really small, but I'm not sure if I can make it bigger. I can't seem to make it bigger. Sorry, everyone. Okay, so what have I just done here? Well, what I've done here is I've created two functions. I've then noted that because functions are objects, I can just take their names. I can use the names as variable names. I can store them as variables inside an array, for instance, or I can store them in an object or in something else or in like a really complicated structure. Then what I've done is I have looped over this array step by step, And in this case, I've used a for each loop. The for each loop, in this case, takes the functions array and it grabs each item one at a time, referring to it as function, or fn in this case. And then I've said, run fn as a function. And it's gone ahead and it's run each of those functions in sequence. This is how event handling kind of works in JavaScript, in that events come in, they get queued up in the event queue, and then they get executed one at a time. So you can pass functions around as variables. Hopefully you're all familiar with being able to do this in C++ as well. I think you've talked about function pointers in C++. It's very much the same thing. It's just that everything is references in JavaScript. So we can pass functions around as variables, which is nice, and then we can run those functions as variables. So how does this come into play with callbacks? Well, I can create a function, which maybe takes I don't know, a variable called sum. Yep. And then a callback. And it might you know what, let's say, let's just make this a function that adds two numbers together and then runs a callback. So it's going to add two numbers together, print them out, and then it's going to call a callback. Dang it. Okay. That's going to call the callback function. I wasn't finished there yet. Okay, so we've got console log a plus b, and then what am I missing here, people? Oh, I'm spelling it functione. Wait, did that work? Yes, okay, that worked. All right. Thank you, thank you. All right, so what have I done? I've created a function. It takes in 3 parameters. The first one is number. The second one is another number. And it's going to add those two numbers together and it's going to print them out. When it's finished doing all of that, then it's going to run whatever function I give it as callback. So in this case, I could do the function name that I'm trying to run, cb1, 1, 2, as the two numbers that I'm adding together. Obviously, that'll give 3. And then I could use our hello function from earlier, like so. I just pass it without the brackets because I'm passing it around like a variable. And if I do that, you can see it added the two numbers together, printed them out, and then it ran the hello function afterwards. This is what a callback function is. A callback function is providing effectively a hook in a function that you've written, or maybe you're given a function that you need to run, and you pass another function to that function as a variable that you can then use to run some functionality, usually after that first function has finished. Now you can do this with anonymous functions as well. When I say anonymous functions, I mean you can just put a function straight in like so. So in this case, I've put the function definition directly in the slot where the variable would go, because the function is just a variable. So because the function is an object, objects can go on variables. So I can just put it all together like that. And oh goodness, I deleted it because of, let's do that again. Yeah, arrow functions are essentially the same. It's just I consider it to be a syntax variation. So I personally like using anonymous functions, but that's just me. but yes, arrow notation is a perfectly reasonable way of doing this. So again, it's going to run CB1, and then when CB1 there, and once this console log a plus b is run, it's going to call this callback function. In this case, the callback function is this whole function right here. And what have I done? Function state requires a name. What did I just do? Take 3 this thing, function. Okay. Yeah, there we go. All right. So in this case, I've taken this entire function just here, and I've put it into this other function in place of this callback variable here. This callback variable here gets run after this console.log statement. So the question is, oh god, lots of questions here. Okay, so what functions in JavaScript handle the network requests? AJAX functions are used to handle the network requests. And one of the things about AJAX requests and certain other APIs is that those requests are non-blocking. So we spent a bit of time discussing the idea that the JavaScript code will run as part of the main event loop. And because JavaScript is single-threaded, it means it just has this main event loop. So any code that you write runs as part of that. And then once it's finished running that, it'll grab the next piece of code out of that event loop and run that. So the queue in the event loop could really just be a queue of functions that need to get run step by step. It's going to depend, it's going to vary on the implementation. I'm not 100% sure the way that it actually works at the low level there, but I've gone on a bit of a tangent here, people. Where was I going with this? Blocking versus non-blocking. So some functions in JavaScript are non-blocking. Sending network requests are non-blocking. I'm trying to think of some other ones here. Timer interactions are non-blocking. So these are special APIs and functions that sit slightly outside of JavaScript itself. And what happens is that when you run one of these functions, for example, a set timeout function, okay, so set I'm trying to remember the syntax for this. I think it's just the function, so it's going to be hello and then the amount of time. People remember the correct syntax for a set timeout function? Oh, milliseconds. Okay, that makes sense. Oh, of course it's milliseconds. All right. 2000. Okay, so it's set it aside and then it comes back with hello after 2 seconds. Now, this is non-blocking. What's actually happening is that this API that provides this functionality, the JavaScript code makes a call to this and it goes off and starts doing its own thing. And while it's off doing its own thing, the JavaScript can keep going and running all the other functions in the event loop. But eventually, this code finishes and it triggers an event back in the event loop. What happens when that event gets triggered? Well, we've already told the code that it needs to run the hello function when this event gets triggered. So this is a way that we can have non-blocking code for actions that typically block. So actions that typically block in JavaScript include timers, obviously. So we obviously don't want our code to stop functioning for the full 2 seconds while we wait for that timer to go. Ideally, everything else can keep running in the background. So instead of code stopping running, the timer goes off into the background and pings us again when it's finished and puts an event in the event queue. Similarly, if we need to send network requests can potentially take seconds to complete, or hundreds of milliseconds at least, through to seconds, depending on how good your network can work. Milliseconds through to seconds, depending on the quality of your network connection and the latency of your network connection. So network requests using the AJAX functions, or using a library like Axios, which is just a nice wrapper around AJAX functions. Those requests provide us with the same kind of callback architecture. That is, you provide them the function that they should run when they finish. They go off, they do their thing, and then they trigger an event that would run that function when they do finish. So, Alan, I've talked a lot around your question, I think. Do you have further thoughts on that question? Yep, I agree. Ajax is good. Yes, so for the most part in JavaScript, from the client side, you'll be using Ajax or WebSockets to handle network requests. And on the server side, I mean, I guess it depends on what kind of network requests you want to make as well, because Node.js allows you to make conventional network requests the same way that you might do in other programming languages, opening up sockets, those sorts of things, and also just sending TCP and UDP packets if need be. But you can also listen for connections. You can also specifically handle HTTP traffic depending, or listen specifically for WebSockets. So it depends on what you want to do with them. Node.js was definitely designed with server-side web applications in mind, but it is still a fully fledged programming language. So anything that you can do in Python, C++, maybe not anything, but the same sorts of things you can do in Java, Python, C++, just other programming languages, you can do in Node.js. You have the console, you have the ability to open and read files, you have the ability to talk to devices and interact with APIs and those sorts of things. So you can just use it as a straight up programming language if you really want to. Okay, so that all. Let's take a quick look at the quiz now that we've had that discussion. So, question: timer events are handled after I/O events in the execution of the event loop. Now that one specifically refers to how Node.js handles the event loop and its order of operations. I'm going to leave you all to take a look at the resource on that because it's pretty straight up stated in there. An event handler that takes a long time to run will block other events from being handled. What do we reckon, people? It's a little bit of both. Some of these you'll find more explicitly documented in Node.js, but this quiz is about JavaScript in general for the most part. handler that takes a long time to run will block other being handled. Okay, let's get a poll in the participants window. Let's get yeses for so green tick yeses for true, red crosses for false. Okay, I'm seeing a bit of a mix here. So in JavaScript, yes, but we know that JavaScript is non-blocking. So what's that all about? So the non-blocking part of JavaScript is that when you have I/O operations, so that is network requests, timers, pretty much anything that requires the language to interact with something that's going to potentially take a while to run, those interactions happen through the use of callbacks. So in those cases, the language is going to trigger an operation. That operation is going to go off and start doing its thing, and the event loop will continue running while that operation is occurring. When the operation finishes, it places an event in the event queue, signaling that it's finished. However, if you have code yourself that you've written that is an event handler, and when I say an event handler, I mean the code that runs when an event is received. It's your code to handle an event. If you have an event handler that has an infinite loop in it and runs forever, because JavaScript is single-threaded, that's just going to keep running forever. And anything that sits in the event queue is just going to wait in the event queue until whatever your code is eventually exits that loop. Now, if it runs forever, it's going to run forever. So it is going to block. So this is true. Even though JavaScript is non-blocking for I/O, it is single-threaded, which means your code can still block. All right, events are handled in the order that they are received. Hopefully that is fairly evident by the use of a queue, so that's a yes on that one. Events are handled one by one. Again, yes on that one. I/O is blocking. Okay, hopefully from what we've just discussed, we all agree that I/O is non-blocking on JavaScript. Code running can be preempted by asynchronous code. Also, a no, it's single-threaded and there is no preemption in JavaScript. So you can rest assured that your code isn't going to result in weird race conditions in JavaScript because it is single-threaded with no preemption. When an event does occur, it will get queued up in the event queue and it will only run once the event has once your code finishes running and allows the event queue to then pick up the next event. All right, events are handled concurrently. Again, no, single-threaded. Received events are placed in a call stack. No, they're placed in a queue. They can be multiple handlers for the same event. This one's not really explicitly covered in the stuff that we talked about, but yes, absolutely, there can be multiple handlers for the same event. We're going to look at a little bit more at the architecture for how that works next week when we start looking at the observer pattern and model view controller as ways of building up events-driven systems. And last but not least, received events are queued. Yes. I really hope I didn't misdo one of those, but I think that's all good. Yeah, so the second question is to describe callback functions and their role in event handling, and I reckon we've just described them in pretty good detail. So if anyone has any questions about that, feel free to ask those questions now. Otherwise, I'm leaving that one to you all. Okay, all right. So that's it for the concepts from this week. Now, I've left some time here or left the second half of this for any questions that people have about exercise 3. I will probably leave some time at the end of next lecture as well, Friday of week 8, for the same thing. If people have questions about how to approach or what they're doing or just whether their Petri nets are correct, those sorts of things. Or even how to go about implementing a Petri net into code. Dallas asks if timers have priority over other events in the queue. That's a good question. I don't 100% know. I don't believe they do. I think the way that it gets, if we look at the resource from, where is it? Here we go. So this one sort of breaks it down. It's not that timers have priority over other events in the queue. It's just that they happen first in the iteration of a single iteration of the event loop. So a single iteration of the event loop will handle any timers that have gone off. Then it will go through the event queue to deal with like any. So it's I don't know about a different priority, but there do seem to be, at least in Node.js, distinctly separate event queues for different types of events. They each get iterated over one at a time. So all of the timers get handled. Then all of the callbacks, pending callbacks in the queue, which would be items from IO operations, for instance, network requests coming back or those sorts of things. And off the top of my head, I can't remember what each of these ones are, but basically the event queues themselves are broken into different sections, or there are different queues, but they all still get handled one at a time. So all of the timers get done, then all of the pending callbacks get done. Then all of these other things each at a time get done. And then once all of that's done and all of those queues have been emptied out, then we go back up and start again. So then any new timers that have arrived at that point, they all get done. And then any new callbacks that have arrived, they all get done. So I wouldn't say that they have priority in the strict sense of the word, but they do get handled theoretically first, even though practically, it's just an infinite loop. So okay. Well, it seems like I'm not getting any more questions in the chat at the moment. So, can you show correct answer for Petrinet? I assume this is from quiz 5, week 5. Yes, okay. sure thing. Let's take a quick look at the actual quiz itself, and then we'll work through the answer for quiz 5. Oh, we're going the wrong way. All right, so we've got the quiz, but the main question was to convert the PetriNet to a DFA. So let's take a look at what that's going to look like. So switch to my camera. And there we go. All right. So what have we got? We have 1, 2, 3, 4. And then we have all right, and this was P1, P2, P3, and P4. All right, so here's our PetriNet, and for reference, I have my markers here to note where the system is currently at any given time. So let's make these transitions a little bit thicker. Okay, and this is T1, this is T2, this is T3, and this is T4. All right, now the marking of the PetriNet can be expressed as P1 is some value, then P2 is some value, then P3 is some value, and P4 is some value. But we can shorthand that down. So the initial state of the system, now, despite the fact that I put red dots on this diagram, that is not the initial state of the system. That is just me saying, hey, the PetriNet is currently running and it's in this state right now. But the initial state of the system is here, like so. So P1 is going to be 1, P2 is going to be 0, P3 is going to be 1, and P4 is going to be 0. That's the initial state of the system. We can express that shorthand as 1, 0, 1, 0. So if we try to convert this to a DFA, we have 4 possible transitions. And our initial state is 1, 0, 1, 0, like so. All right, so first question is, which transitions are enabled for this PetriNet? Is T1 enabled? Okay, yeah, 2 and 3, exactly. So T1 is not enabled and T4 is not enabled. So we've got T2 and T3, and those are the 2 enabled transitions. So let's step this through. If we take T2, where does that put us? That puts us here. So that's going to be nothing in P1, once in P2, once in P3, nothing in P4. So it's going to be 0, 1, 1, 0. If we fire transition T3, that's going to consume 2, and it's going to produce 2 into here. So that's going to put us into 0, 1, 0, 1, like so. So those are 2 new states. Like so. That's our initial state. All right, so starting here, which transitions are enabled? That's this one just here. Yep, exactly. So only T1 is enabled. T3 is not enabled because both of its input conditions are not satisfied right now. So only T1 is enabled. So if I do T1, that puts me back to what was the initial state. So 1, 0, 1, 0. All right. Now the other option that we had was 0, 1, 0, 1. And what transitions are enabled from here? Right, we've got T1 and we've also got T4. Exactly. Yep. So a T1 is going to take us to here, which is going to be 1, 0, 0, 1. T2 and T3 are not enabled. T4 is enabled, and if we take that, that's going to put us into 0, 1, 1, 0. Okay. So finally, we have this one here. What transitions are enabled? It's only T4. Oh, actually, it's T4 and T2. That's a good point. Okay, so T4 and T2. So T2 puts us from P1 down to, or puts us into this state again. So that's going to be 0, 1, 0, 1. And T4 is going to put us back up to here, which is our initial state. Okay. All right, and that is the full transition table that we end up with. And I guess just to draw that out as a DFA, if anyone wants to see that drawn out as a DFA. So making that A, B, C, D. So if that was state A, so B and, so that's T2. Okay, B with a T1 gives us A. And C with a T1 gives us D. And C with T4 gives us B. And D with a T2 gives us C. And D with a T4 gives us A. Okay. And that is the full solution. If you think there's any issue with the way that you've been marked for this one, zap me a message on my uni. I'll go in and take a look and correct it if anything. There are 2 T4 coming out of, oh my goodness, what did I do there? T4 is, oops, I was reading the C column. Okay, hang on. Good call, thank you. C with T4 is B, so that is also T4, thank you. That is why I like to use the table method. The table method, well, this is why I personally prefer the table method when I perform these conversions, because I find it's easy to get lost in the diagrams. Oh, goodness, okay. Thank you. I will correct that. There was a whole thing when EDC moved from a level 3 to a level 4 course, but the SBN is meant to stay the same. Okay. Although I didn't think I had submissions for the project, but let's... Okay, there we go. Okay. Yeah, I expect that that would show up for the logbook. About last week's lecture, is there any specific way of dealing with states that on being given a certain input lead to a deadlock state? This was specifically related to combining dual FSAs, or was that more on Petri nets? Dual FSAs. Not that I'm aware of off the top of my head. I think that's just something that's inherent with combining two FSAs together in that manner. It might be that you want to it might be that you come up with a more complex input mapping for the system to prevent it from ending up in that place to prevent it from reaching that scenario in the first place. But no, I think that's inherent in the way that you are taking two existing systems and synchronizing them over a set of inputs. No worries. Does anyone have any other questions for today? No worries, Alvin. Now, it's worth noting that I think there was one of the questions was a bit whack in last week's quiz. It was the reachability question, though, not the deadlock question, I think. Yeah. So the idea of deadlock is simply if you have an FSA, any FSA, regardless of whether it's a dual FSA or a single FSA or whatever, if you ever have a case of, so let's say, something like this, and in this particular case, I can move freely back and forth between these two states as much as I like. That's all good. But as soon as I get to this state, I have no outbound transitions that I can take. So this is considered deadlock right here, because if I ever end up here, there's nothing that I can do that doesn't kill the system as a whole. So for the week 6 quiz, I can see I have to make the week 7 quiz actually appear in the module section. One moment. It's been published, but it wasn't visible. There we go. No, it's not considered deadlock if you can loop back to that state. So that is not deadlock because I can still take that action. Whereas if that wasn't there, this is deadlock. Because the question was just, can this particular DFA system deadlock? Yeah, Ting Shen is on the money with this one. It's if you convert the system out to a DFA, or if you convert it into a DFA, a set of DFA tables. So in this scenario, we had very quickly, we had, what did we have? We had Q1, Q2, Q3, and okay, so Q1 with A, B, and C, so is Q2. I'm just going to write them as numbers because that's easier. C is Q3, Q2 with a B is Q3, Q3 with an A is Q1. Okay, so it's like, okay, that was that whole system. And we had 2 of them. So the system starts out in Q1 in both. So we had P is, so we have P equals Q is C, C nothing, R is nothing, A, and S is A, C. All right, so, okay, so Q1 with a P is going to be B's on Q1, which gives us Q2, sorry. With a Q is going to give us a C on the first one. That's going to put us into 3-1. R is going to be an A on the second one, so that's going to be 1, 2, and S is going to be an A on the first one, a C on the second one, so that's going to be 2, 3. So 3, 1, 1, 2, 2, 3. Question says, what if we were saying that this was a deadlock state and it was an accepting state, is it still a deadlock? Yes, there is still a deadlock. Now, this is fine if you don't receive any more inputs once you arrive here, but if you were to still receive inputs, there are no valid outbound transitions for those inputs to take, so the system is still deadlocked in that scenario. All right, 2, 2. So the only thing that we can take are B's here, which is none of these other ones do B's, so they all die. 3-1. Let's see about 3-1. So basically, if it's anything but an A in state 3, so R could give us a 2. So R would give us 3-2, and S would give us 1-3. And Q would break, and P would break. And so on and so forth. We just keep working through this one. And what you'll notice as you work through this one, if you get a row which is all dashes, then there is a deadlock in the system. So very quickly, let's take a look at some of the ones that could potentially give us deadlock. So 2-3, if we arrive into state 2-3, and R will take us out to 2-1, and if we arrive in, okay, so 3-2 we say. Okay, so yeah, if we're in state 3-2, from state 3 we need an A, so it needs to be something with an A. And from state 2 we need a B, it needs something with a B. So we would need A, B, or we would need A, nothing, or nothing, B. None of those are valid. Therefore, this would be a deadlock state. Yep. And we've seen that that's reachable from state 3-1. So an input sequence of Q, then R would put us into a deadlock. Okay. Does anyone else have any other questions? I could just keep going with this table. Oh, good. Have I missed any states in here? 3, 2, 2, 1. Haven't got a 2, 1 yet. We got a 1, 3. I don't think we have a 1, 3. All right. feel like I've made a mistake here. What's this? 1, 2 with a Q. No, that works. Okay. 1 with an RS and A, that's not going to work. Nope. And I think that just leaves 1, 3. Let me know if I've missed any. So 1, 3. C is obviously going to give us 3. Oops, sorry, Q is going to give us 3. 3. That's going to be null. R is going to give us 1, 1. And S is going to give us nothing. And I think that's everything. 2, 1 with R is 2, 2. Oh, so it is, thank you. Which we have back there. All right. If no one has any other questions, I'm going to call it there for today. Everyone have a good weekend, and we'll pick this up again next week. Please do take a look at your exercise 3s if you haven't already taken a look at them, and feel free to bring any questions you have about that to our Friday session next week as well. As well as asking them on Piazza. Yes, Albert. Don't tell me next week is a public holiday. I don't think it is. No, it is not. Yeah, absolutely. Happy to take a look at your picture now. Bear with me 1 moment. I'm just going to... it's in your SVN, okay.